In this video, I'm going to look at two different solutions to the Cowgirl problem. These solutions are exactly the types of solutions that I employed when solving the burning tent problem, which you'll find in my March 2021 blog post on Sign of the Times. Here's the situation. We have a cowgirl at point C. She's on a horse, and she's going to ride her horse over to the pasture to get something for the horse to eat, and then to the river so the horse can have a drink, and then back to her tent. And the question is, where should we place points A and B so that the overall distance that the cowgirl rides on her horse is minimized? The first approach to this problem is going to use the reflect tool. So if I tap on this tool, I see a preview of what I'm about to construct. A point, which is glowing, a mirror line, and the reflection of that point across the mirror. So I'm going to start by reflecting the cowgirl, point C, across the pasture. So I'm going to merge this glowing point to point C. I'm going to merge the mirror line to the pasture. And here we have the reflection of point C. I'll tap on my label widget, and let's just call this C prime. All right, now I'm going to do the same thing with point T, the tent. I'm going to reflect that across the river. I'll tap on the reflect tool. I'll merge the glowing point to point T. I'll merge the mirror line to the river, and here we have T prime. Let's label that. And to make this a little easier to think about, let's add a segment between C prime and A. And let's add another segment between B and T prime. So how does this help us? Well, if I'm traveling from C to A to B to T, that's really the same distance as going from C prime to A to B to T prime because of the property of reflection. So really what I want to do is find the shortest path between C prime and T prime, and that clearly is not this path here. Let me highlight the path here that we're trying to minimize now, and I'll color these segments red just so they're easier to see. All right, so we're trying to minimize this red path. Clearly this is not the minimum, and I can move A and B until I have a straight line. The other way I could do this, to be a little more precise, is to move these out of the way and then use my segment tool to simply connect C prime to T prime. So really nice solution. However, there's also another approach, and I didn't even know this other approach would work here until a student of mine, a pre-service teacher at NYU, came up with it after doing the burning tent problem. So on page 2, here's our situation again with the cowgirl, and this time we're going to use an ellipse, just like we did before. So I'm not going to go into all the reasons why the ellipse is a good tool here. You can watch the burning tent video to get a little more insight into the properties of an ellipse and why it works well. But let's take a look at what's going on here with this approach, because it's really clever. So we have the first leg of our journey is from C to A to B. And you can think of that in a way as just a version of the burning tent problem, from traveling first from one point to another with a destination in between. And we saw with that we could use an ellipse to find the location for A that would minimize that total distance. So we're going to think of points C and B as fixed and ask, how can we find the best location for A? So I'll tap here on the ellipse tool. I get a preview of the ellipse I'm about to construct with one of the focal points glowing. I'm going to merge that focal point to C. I'm going to merge the other glowing focal point to B. And the point that's on the ellipse, I'll merge to A. So as we saw before, because the ellipse is not tangent to the pasture, this is not the best location for the ellipse. And while I'm at it, let's color the ellipse red. It'll make it easier to talk about in a minute. So that's not the best location, but for the moment, let's move on and look at the second leg of our journey, which is from A to B to the tent. And let's imagine that A and the tent are fixed in place, and we want to find the best location for B. Well, we can use the ellipse approach again, this time making A a focal point of the ellipse, T a focal point of the ellipse, and B a point that sits on the ellipse. And let's color this ellipse blue. So really, if we're going to find the best location for A and B, we need both of these ellipses to be tangent to their respective lines, either the pasture for the red ellipse or the river for the blue ellipse. So let's at least get started with the red ellipse. I'm going to drag point A until this ellipse is tangent to the pasture, so somewhere around here. And now that I've done that, well, the blue ellipse is definitely not tangent to the river, so I better drag point B. So let's move B, get that to be tangent somewhere around here. Okay. Oh, but look what happened. Because I dragged B, and B is the focal point of the red ellipse, now my red ellipse is no longer tangent to the pasture, but the situation's improving. I can drag point A to make it tangent, and it's a little hard to tell precisely when these 2 points are tangent, but I can keep going back and forth between them until both of these ellipses are tangent simultaneously to the red ellipse to the pasture and the blue to the river. A very clever approach to taking the solution to the burning tent problem and applying that here with 2 ellipses.